Hello there, my name is Grace Gindi. I'm a final year computer science student in Indonesian University. And me and my friend Glenn Lionelli, we've been trying to publish our research paper titled Word-Level BISINDO, a novel video Indonesian sign language dataset and baseline methods. And we've just got the acceptance certifications. It turns out we've got accepted to a conference. And here's a recap of our research. First of all, why BISINDO matters? Just a background fact, there are two kinds of sign language in Indonesia. The first one would be CB and the second one is BISINDO. So BISINDO or Bahasa Isyarat Indonesia is the primary sign language used by the deaf community in Indonesia. It differs from the government standard CB, which is mainly used in formal education. And while CB has institutional support, BISINDO, despite being preferred by the deaf community, is still underrepresented in digital resources and public datasets. This is really concerning, given that Indonesia contributes around 3 to 4% of the global deaf population. So we've been trying to dig deeper around the datasets and the models used in sign language recognition. And for the datasets, we found that over the years, several countries have developed ISL datasets or isolated sign language datasets, such as WLISL, LSA64, SLOFO, GSL, AUTSL, and many more. These datasets have contributed greatly to advancing sign language recognition using deep learning. However, when it comes to Indonesian sign language, existing datasets are very limited and often only cover alphabetic or numeric signs. There is little to no publicly available dataset for word-level BISINDO. So our work introduced WL BISINDO to fill this critical research gap. And next, we've also dig deeper around the models used in sign language recognition, and we found that sign language recognition, or SLR, commonly uses two approaches. The first one would be pose-based models, and which analyze body and hand joint positions like spotter and reformer. And the second one is visual-based models like NVITV2, which learns directly from video frames. We use transformer-based architectures in both cases because transformers are deep learning models that excel at capturing spatial and temporal patterns, making them ideal for understanding complex gestures and in sign language. And this is the flowchart in our methodology. We've prepared and annotated 1,600 videos of 32 isolated BISINDO signs performed by 5 scientists from Banten. These videos were processed and evaluated using 3 transformer-based models, which are spotter reformer and MVITV2. And each model has its own pre-processing pipeline, but all follow the same evaluation protocol. So the WL BISINDO dataset is the first public BISINDO dataset at the world level. It includes 32 commonly used signs captured in controlled environments to ensure clarity and consistency. These are the examples of the signs we included in WL BISINDO. like terima kasih or thank you, like this, and then truly or deaf is like this, and many more. These signs are frequently used in daily communication within the deaf community in Indonesia. And after we input the dataset to the models, we found that in the sign-independent setting, where the training and test data include the same signers, all of the 5 signers, and VATV2 achieve the highest accuracy of 97.08%, followed closely by Spotter and Sifomer at around 93%. While in the signer independent setting, we use leave one subject out cross-validation, training on 4 signers and testing on the remaining 1 signer. This evaluates how well the model generalizes to unseen individuals. In this scenario, Sifomer outperforms Spotter in 3 out of 4 experiments, showing stronger generalization across different signers. However, for signer 3, it is shown that the accuracy drops significantly due to their faster signing speed, which results in fewer frame speed captures, and this causes missed key points and disrupted post estimation, highlighting the need for better handling of variations in signing speeds. And to conclude, Word-Level BISINDO provides a solid foundation for BISINDO sign language recognition in Indonesia and inclusive technologies in Indonesia. Based on this work, future research should explore around continuous sign language recognition or CSLR, sentence level recognition, and even sign language translation or SLT. These tasks will require larger, more diverse datasets, including signers from multiple regions and natural signing styles, along with more complex annotations and standardized splits for training, validation, and testing. And last, thank you for your attention. We hope Word-Level BISINDO serves as a stepping stone toward more inclusive communication technologies. The datasets and models are available publicly on GitHub for further research. Thank you.